Hi everyone, I am Yogadharani, working as Assistant Professor in Department of Computer Science and Engineering at SNS College of Engineering. In previous videos, we saw about introduction of IoT, its applications, components, what is the IPv6 role in IoT, then IoT general definitions, what are the two views in ITU T views and its architecture. Now we are going to see about working definition. So a broadly deployed aggregated computing or communication applications that is deployed over a local, then metropolitan, then regional, and it's global, consisting of three modules. First one is depressed instrumental objects things which embedded with one or two way communication and sometimes no computing capabilities, where objects are reachable over a variety of wireless and wired LAN or wide area network. And the third one is whose inbound or outbound commands are pipelined to or issued by a system with a high degree of human or a computer based intelligence. This is the working definition of IoT. Then other related definitions such as it has two other related working definitions are sensors and actuators. I already told about sensors and actuators. That is, sensors are active device that measures some variable of the natural or man-made environment. Example, building an assembly line and industrial assembly supporting a process. Definition of an actuator is a mechanized device of various size, that is from ultra small to very large, that accomplishes a specified physical action. For example, controlling a mechanism or system, opening or closing a valve, starting some kind of rotary or linear rotation, or initiating physical locomotion. That is, an actuator is the mechanism by which an entity acts upon an environment. Then IoT definition, working definitions are an object is a model of an entity. That is, an object is distinct from any other object and its character by its behavior. An object is informally said to perform functions and offer services. That is, an object that perform a function available to other entities and the object said to offer a service. See, this is the IoT definition of working definition. See here in this diagram, class object classification. In first one is object, then IPv6 address, belong its size, mobility, then power, connectivity, automation, physical layer, and network layer. IoT working definition and its characteristics are objects have the following characteristics such as has the ability to sense or and actuate and IoTs are generally small but not always. Here IoT working definitions and object characteristics have limited computing capabilities but not always, and object characteristics are energy or power limited, and these are connected to a physical world, sometimes have intermittent connectivity, and sometimes are are mobile but not always, interest to people, and also managed by device, not people but not always. IoT definition, working definition, basic element. So this is the diagram shows a basic element of M2M, which is machine to machine application. So here M2M or H2M stands for human to machine environment compromises three basic elements. And then first one is data integration point, that is DIP, and then the communication network, then the data endpoint, that is DEP, again a machine M. So in this block diagram, X is a sensor or a application which is connected by one end. So one end is connected with the application and another end is connected with the communication network. That is typically a DEP, a machine in human environment, is engaged here. It's a microcomputer system. Here one end of machine which is connected to a process or to a high level subsystem via a special interface. The other end is connected to a communication network. And then a DIP can be a, that is a data integration point, can be a internet server, a software application run on a firm resistant host, or an application implemented as a cloud service. So today we saw about IoT working definitions, its a block diagram and explanation of that. And the next video we would like to saw about IoT frameworks. Thank you.